Hey everyone, Mr. Strider here. So today we're going to start off with solving multi-step equations. So this is stuff that you should learn in Algebra 1, Math 1, whatever your uh, state calls it. Um, but in general, it's the same thing as solving a regular equation. We want to get x or whatever variable it happens to be by itself. So in this case, I want to move some terms around so that I can get all my x's together. And then I want to get all my constants or numbers that don't have a variable on the other side. So the way I'm going to start this problem is whenever I see parentheses and a number out in front, I'm always thinking distribute or the distributive property. So that's the first thing I'm going to do is I'm going to distribute this 3, or that's just a fancy word for saying we're going to multiply 3 by everything inside. So 3 times x is 3x, 3 times x. 3 times 1 is 3. And we still have equals 5 plus x. So once I've distributed this out, now you can see I have 3x over here and I have an x over here. So my next step is going to be to get the x's together or on one side of the equation. So you can do it either way. You can move this x to the other side, or you can move this 3x to the other side. Now, my tip is always to keep your variable term positive. So if I move the 3x over, I'll end up with a negative something x, and I usually don't like to work with that, but you can still get the answer that way. But what I'm going to do is I'm going to move this x to the other side. And again, anytime you're working with an equation, you're always going to do the opposite. So if this says plus x, or it's a positive x, I'm going to subtract x. See, it's kind of hard to see that. Yeah, so minus x, and minus x from there too. And again, remember, there's really just a 1 in front of x. Well, x minus x cancels. 3x minus 1x, I have a total of 2 x's, 2x. And I'm going to rewrite what I have left. Plus 3 equals 5. Now, just like we moved the variables to one side, we're going to move the constants to the another side so that they're by themselves. So in this case, I'm going to move the plus 3 to the other side. And again, since it's positive, I'm going to subtract 3 from both sides. 3 minus 3 is 0. So those would cancel, leaving me with 5 minus 3, which is 2. Bring down the 2x over here. So I have 2x equals 2. And now to get x by itself, now that we got our variable term by itself, we can then do the opposite of this, 2 times x. Well, that's opposites to divide. So if we divide both sides by 2, 2 divided by 2 is 1. Well, 1x is the same thing as x. And 2 divided by 2 is okay. Now a great way we can double check our answer is if we take the 1 and plug it back in for x to double check to make sure we got it right, which I'll do mentally real quick. Well, if I plug 1 in here, 1 plus 1 is 2, 2 times 3 is 6. Well, 5 plus 1 is 6, 6 equals 6. Yes. So that is the basics of how to solve a multi-step equation. Continue watching and we'll learn how to tackle a multi-step literal equation, which is stuff like formulas or stuff with a lot of just variables involved. So we'll take a look at that next. So stay tuned. All right, so we're back with a multi-step literal equation. So you can see there's quite a bit of stuff going on here. We got multiple variables. We got an M, we got a G, a B, and a D. And the goal here is going to be solve for B. Okay, so I want to get B by itself. So just like a regular equation with mostly just numbers and one variable, we're not actually going to have a finite answer here. So B equals 5, B equals 10, B equals -2. We're not going to have something like that. We're going to have B equals some sort of variation of variables, okay? And really, it's just going to be doing the opposite to everything over here so that we can get this b by itself. So the very first thing that I'm going to do is I'm going to move this negative 4g to the other side of the equation. And just like if it was minus 4 and we didn't have this g part here, we can still move the negative 4g over by doing the opposite. So the opposite of subtracting 4g is going to be plus 4g. Well, if I add it to this side of the equation, I also have to add it to this side, and I'll just do it right here. So negative 4g plus 4g, those are going to cancel. And then over here, I'm just going to be left with, oops, me, put the m first, m plus 4g. And then I can bring down this db squared. Move out of the way a little bit. So I'm left with db squared equals m plus 4g. Now, I don't have the b by itself yet, but I do have this d that's in front of it. Well, think about what operation this is. There's a number, or not a number, I'm sorry, a variable next to a variable. Well, that just means multiplication. So if I have d times b squared, well, the opposite of multiplication is going to be division. So in order to get this to cancel out, I would need to divide both sides by d. And what that's going to do, d divided by d is 1. So I'm left with b squared equals m plus 4g over d. Okay. Now, I was supposed to solve for b. I have b squared. Well, the opposite of squaring something is going to be taking the square root. So if I just want a b here, I need to take the square root of both sides. Okay, so if I do it on this side, move my equal sign a little bit. I also need to take the square root of the other side. And what will happen is the square and the root will cancel each other out, leaving me with just b equals m plus, oh, there's a plus sign there, plus 4g over d, and the square root of all of that. So let's see if I can make this a little cleaner. Square root's always a little big. So this would be my answer. And again, like I said, it's not going to be b equals 5, b equals 100. This is b equals the square root of m plus 4g all over d. All right, and again, the reason this is useful is because if you're working with formulas such as the distance formula or the area of a triangle, the area of a square, you can manipulate those so that you can solve for the thing that you're looking for. So for example, if you're working with the area problem with a triangle, and you know the base and you're trying to find the height, and you know the area, you can rework or rearrange that formula to where it says h equals something, and you can plug in the stuff you know, and it'll give you the h that you're looking for. So if you found this useful, let me know. I'll see you guys in the next video where we'll be talking about linear functions and evaluating functions. So see you then.